Dear students, we are in 6.5 exercise minima maxima. Okay, two classes already we have finished. We understood what is minimum value, what is maximum value. See, we understood what is minimum value and maximum value, but we have not gone for minima or maxima until now, I suppose. Okay, and we have understood the concepts, the example we have taken, and afterwards we have gone for exercise. And two questions we have completed. First question contains 4 parts, second question contains 5 parts. Okay, total 9 questions we have done. Now you see, now concept has been little bit changed. Now new concept is local minima, local maxima. Local minima, local maxima is different from local minimum value and local maximum value. Okay, minimum value, minima, maximum value, maxima, both are different. What are these differences and all we will understand now. See, here we are going to adopt first derivative test, second derivative test like. What is first derivative? First derivative is normal differentiation. What is second derivative? Second derivative means differentiate again the differentiated function. 2 times derivation. Okay. These tests, how they are helpful for finding us this maxima value, minima value, local minima, local maxima, and maximum value, minimum value, or we will understand. Okay, after this we will take one example and we will go back to exercise 3 and 2 questions we will do in exercise 6.5. Third question contains 8 parts, 2 parts we will do. Okay. See, let us understand. First you understand the graph. This graph already we have drawn for understanding maximum value, minimum value. You see here this is V shape, here again inverted V shape, again inverted V shape, like is there. A, B, C, D points you understand. See, here you have to understand some concept. I am talking about, you see, I am talking points. I am talking values. Okay, how these values are, how these words are important also you have to understand here. A, B, C, D are points. Okay, A, B, C, D are points. A comma C, points of local minima. Local minima, local maxima. A and C are points of local minima. That means A is local minima. What is local minima? What is A? A is a coordinate in X. A is a coordinate in X. C is a coordinate in X. B is a coordinate in X. D is a coordinate in X. Okay? That is why points A, C are points of local minima. Okay? Local minima. Okay. Points whether you write or not doesn't bother. But if you write local minima, it is a X coordinate. You see, again I am talking. See, if at all f of A comma f of C, you see, not A, f of A, not C, f of C. What are these? These are local minimum values. You understand now? Local minimum value. Local minimum value means f of x, f of A, f of x. See, this is x. This is f of x. F of x we will plot on y, x we will plot on x axis. Okay? A, B, C, D is under. At A, f of x is having some value. At C also f of x is having some value, f of C. Okay. F of A, f of C. These are local minimum values. Local minimum values. You see, here values have come. Here value has not come. Only minima. Minimum values, minima. Minima, minimum values. Both are different. That you have to understand. Okay. See, if at all AC are points of local minima, then what about points of BD? BD, points of local maxima. See, first of all, minimum value, maximum value, minimum value, maximum value, already we know. We have done questions also. That is why we are able to understand immediately. And this we can call as local minima. This we can call as local minima. This we can call as local maxima. This we can call as local maxima. The value at this point is local maximum value. The value at this point is local minimum value. Okay. Likewise, you see here, f of b, comma f of d are local maximum values. Okay. See, again I did not tell why this is being called as minima. Why? Because here goes on decreasing this. Afterwards, after this point, turning point, this is goes on increasing. See, whether it may be increasing or decreasing, but these points we were called earlier as turning point. You see here, say B is a turning point. A is also turning point. Now, while come to local minima, local maxima, this we are calling as critical point also. That means both are same. See, concepts slowly we are getting more and more concepts. Earlier we called it as turning point. Now we can call it critical point. Why turning point? Turning point means it is changing the direction of the value. See, earlier decreasing was there. After this turning point, again increasing has come. If you see with B, earlier increasing was there. After B, decreasing will come. Like this, critical point also. Okay, critical point also. Earlier decreasing, afterwards increasing, or earlier increasing, afterwards decreasing. Like this, increasing, decreasing, increasing, decreasing is there. Okay, this is the local minima, local maxima concept. Okay, local minimum value is different from local minima. Local minima means a point, x coordinate. Local minimum value means that value, that point you have to substitute in the function. F of x is the function. If b is the local maximum value, local maximum point, that point f of b will be local maximum value. Local maxima, local maximum value. Local minima, local minimum values. Okay. If you understand this, then we will go for first derivative test. Okay. See, earlier normal maximum value, normal minimum value we have done. Or else neither maximum nor minimum value also we have done. Okay, here also neither maximum nor minimum value will come, but what we call it also is there, some word is there, that also we will understand. Okay, let us go for first derivative test. Okay, see, we are doing first derivative test. Okay, see, what is the first derivative? See, first derivative means derivation. Okay, you see, this is a function f of x. Okay, you have got f of x. First derivative test means what you are doing, usually step by step you have to write. First you write the function, then you write f dash x. F dash x is the first derivative. Why? Because only one time you have done, that is why first derivative. See, here second derivative is also coming, that is why we are calling it as first derivative. Or else we will tell this as only derivative test. But this is not derivative test, this is first derivative test. F dash x. F dash x you do with any function. Afterwards what you have to do, you make f dash x is equal to 0. Okay, see process what we are doing, you write f of x, you do the first derivation of f of x, f dash x will come, you equate it to 0, f dash x, then you will get x value, that value may be c. Okay, now you write here, see that point. See what is c? Normally f of x is having some what we can say, interval, open interval or something like. Okay, see, closed interval means that we'll discuss about afterwards. Absolute minimum, absolute maximum will come, but that will different after that, discuss afterwards. See here, this c is in between the any one point in the domain. Okay, this is c. See, here is this c. See, if you make a derivative test equal to 0, one point will come. That point will be critical point. Again, see, here C is critical point. Okay, see here in derivative test, this critical point is having three values, three types. That may be critical point C may be local minima. Okay, C may be local maxima, C may be neither local minima, local maxima. Point of inflection. Point of inflection. Point of inflection. Okay, now one by one we will understand. Okay, come back here again. You see here what we have done, f dash x we have done, and we have got f dash x is equal to c. That means here shall I write like this? F dash c is equal to 0. Why? Because f dash x is equal to 0 means x is c. F dash c is equal to 0. Shall I write like this? Definitely I can write. You see, you have done derivation means, see, what is derivations? Derivation is a rate of change of function. You goes on changing the function. Okay. You see here, if you change this here, logically f dash x in this portion, because it is increasing, is going to become greater than 0. Is it okay? Positive only, na? Change in positive side means increasing. Change in negative side means decreasing. Here, f dash x will be less than 0. Why? In this area it is decreasing. We can write this also. Here it is increasing, here it is decreasing. And also another symbol also we can write. You see here, increasing means positive, decreasing means negative. Okay. Logically also, from positive to negative or negative to positive, will change the sign after 0. Okay. See, negative afterwards 0 will come, afterwards positive will come, real number line also. If you want to come that side, reverse side also, positive 0 then negative. Like this one. Okay, you understand now? Same thing here also. See, what we call here f dash c. See here, rather than calling point, directly we will call f dash c. Not f dash c, f of c. F of c will be here I am talking about. F of c will be local maximum value. Local maximum value. Why? You see, local maximum value, it comes when derivation from positive to negative sign changes. Sign change also I am writing, you see here. Why? Because see, now we are doing sign change. We are doing derivative. That way sign change also have to take. Sign change. Sign change. Why? Because here sign is important. We will do after second derivative also. Second derivative also sign is important. What is sign? Sign means greater than 0 or less than 0 or 0. If less than 0 is negative, greater than 0 is positive, that's all. See here, greater than 0 increasing, that is why positive, to negative, less than 0 decreasing will come. Sign change. That is why we will call this as first derivative test. Okay. See here, from positive to negative changes, that function, that point value, local maximum value. See here, finally, for value, you are going to take f of c only. What is this c? C is a point we will get after making the first derivative test equation to 0. Okay. Same thing you come here. By seeing itself it is a V shape, we can call this as local minimum value f of c or local minima. C is local minima. Okay. Here also you see, same thing we have done. First derivative f dash x equal to 0 means x is equal to c will come. That means here also see f dash c is equal to 0 will come. Will come or not will come? F dash x c is equal to 0 like here. Okay. But see, before that here f dash c, what will come here? F dash c is negative. You write down. F dash x is less than 0. Why? Because see here goes on decreasing, afterwards goes on increasing. That means here f dash x is greater than 0. That means this is negative, this is positive, this is decreasing, this is increasing. Is it okay? See here sign change happened, but sign change from negative to positive change happened, but the point, critical point, at that critical point, f of c, here critical point is c, f of c is going to be called as local minimum value. Local minimum value. See here local maximum value, here local minimum value. But now you see what is the difference, like earlier we were not done first derivative. Earlier we were having turning point, now we are having critical point. Critical point comes after first derivation, equating to 0. Okay. Function at critical point is going to be called as either local maximum value or local minimum value. If at all derivation of the function changes from positive to negative, that point is going to be called as local maximum value, local point, not point. That way, or else point you can call. That point is going to be called as a local maxima, and value at that point is going to be called as local maximum value. Okay. If at all first derivative sign changes from negative to positive, the point which is critical point is going to be called as local minima. The value at that point is going to be called as local minimum value. Okay. This is the concept of this thing. Okay. See, we have not yet gone for a point of inflection. Okay. See, here we are doing derivation. We know that change is in the negative side, negative will come decreasing, changing, increasing, then positive will come, all we know. But what about if it is a function is not derivatable? One function also you know, modulus x. Modulus x at x is equal to 0, not derivatable, not differentiable. See, before 0 it is differentiable, after 0 it is differentiable. Which one? Modulus of x. But at x is equal to 0, modulus x is not differentiable. But can we find local minima, local maxima? Yes, definitely we can find. See, where it is not differentiable, there you have to make that point as C, critical point. Here, modulus x is not differentiable at x is equal to 0. Then that point you have to make as C. Okay? It may be differentiable but equate it to 0. If it is not differentiable, that you point take as the critical point. Here 0, that's all. You understand? That means, see, this is applicable. Local minima, local maxima, we can find the functions for differentiable and not differentiable also. Okay? Okay, that is one thing. Then what is the point of inflection? We will understand point of inflection also. Okay, see, to understand the point of inflection, again one graph I am drawing, plotting, you understand this first. Say this is y is equal to x cube or f of x is equal to x cube. Okay. If you give negative input, all numbers will come in negative only. Cube is there. Okay. If you give positive, all numbers will come positive only. But here, unlike this one, or unlike this one, is there any turning points, critical points? You tell me. Critical point means after that point the sign has to be changed. After this point sign has to be changed. That means decreasing, then increasing, then increasing, then decreasing. Okay. That is why here critical points are there. Local maxima, local minima are available for this. But come here at x is equal to 0. Say this is 0. At x is equal to 0, if I ask you to find, what you are going to find? Is there a local minima, local maxima available here? You understand carefully. Why? Because see, here also f dash x is greater than 0 only. Why? Because see, if you increase, goes on increasing. Afterwards also, f dash x is greater than 0 only. That means, see, symbol I am talking, sign, here also positive, here also positive. Is there any negative or sign change? Why? Because see, goes on increasing, afterwards also goes on increasing, but in between 0 is there. Here you have to understand, positive, but between 0. This 0 at x is equal to 0, 0 is point of inflection. This is called point of inflection. Point of inflection means neither minimum value nor maximum value exist. That means neither local minimum value nor local maximum value exist, like you have to write. Then what is that? At x is equal to 0 is the point of inflection. Here no value. Value means 0 only here. Okay? Value means 0 only. Any function that point you have to submit. Here x is 0, critical point. 0 if you submit, here automatically y is going to become 0. F of x is going to become 0. Value also 0. Positive, 0, positive. Okay? This is called point of inflection. You understand now? But this is not the case for local minima, local maxima. Sign changes is occurring. Sign change is occurring. Here sign change is not occurring. Both positive, positive. See, don't confuse here. This is minus y. I am talking about derivation. First derivation. First derivation is goes on increasing. That is why positive we will take. Sign. Here also first derivative goes on increasing, positive we will take. Okay. Don't think that this is plus y, this is minus y. That is why here minus you are taking. No, not like that. Why? Because goes on increasing. When you take minus if it is in this condition. Afterwards, if it is in this condition, this is positive, this is negative. Why? Because this is decreasing, this is increasing. Derivative. Okay. Now you see, we understood the point of inflection, local maxima, local minima, local minimum value, local maximum value with first derivative test also. Now we will go for second derivative. See, I am writing second derivative test. As written, second derivative test means second times you have to differentiate the function. Okay, see, this is the function f of x. Next, what I have done? I have done f of x, f dash x, and I have made it equal to 0. Then I received one point f of c, and c will be critical point. That may be local minima, local maxima, or point of inflection. I don't know what is it. Okay. See, afterwards again I have made second derivative, f double dash x. F of x is a function, f dash x is a first derivative, f double dash x is second derivative. See, second derivative already you are having c. Second derivative f double dash c is greater than 0, f double dash c is less than 0, or f double dash c is equal to 0. Three conditions will come here. Okay, why? Because see, you have made first derivation and you have made it equal to 0, then you have got one point, x is equal to c. That c you are substituting in the second derivation. Second derivation also you are doing. After doing the derivation, then you substitute this c here. F double dash c, if it is greater than 0, then here If it is greater than 0, C is point of local minima. See, logic you understand here. Greater than 0, if it is in first derivation, then increasing. But here, if f double dash 0 is greater than 0, that means positive value. Greater than 0 means positive value. If f double dash c is positive, then local minima will come. F double dash c is less than 0 is come, then c is local maxima. Point of local maxima. Okay? Understand carefully. Second derivative comes less than 0, negative, then local maxima. Accordingly, local maxima value. Second derivative is greater than 0, then local minima. Accordingly, local minimum value. You substitute C. Okay? C. What if f double dash c is equal to 0? See, directly don't write point of inflection. Point of inflection may come, or else local minima, local maxima also may come. You have to go back to first derivation. If second derivation comes 0, then go back to first derivation and apply this C. And see what will come. Okay? If that comes like this, first derivative, then local minimum value will come. If it comes like this, local maximum value will come. If it comes like this or like this, point of inflection will come. Why? Because goes on increasing. Here also goes on increasing. There is no minimum value, maximum value. Local minimum value, local maximum value. In these two cases, or in this case also, you see, goes on decreasing. Goes on decreasing. Both are goes on increasing, goes on decreasing. Point of inflection will come. Why? Because there is no sign change. Increasing, increasing. Any point if you take, afterwards also increasing. Any point if you take, afterwards also increasing. Any point if you take, before that point also decreasing, after that point also decreasing. Before that point also decreasing, after that point also decreasing. That is why here point of inflection. At point of inflection, normally value is 0. Okay? Point of inflection you can write and close. But here not that case. Local minima, local maxima, local minimum value, local maximum value, because of first derivation. Okay? For second derivation, if comes 0 only, then you go back to first derivation. Or else if it is greater than 0 or less than 0, directly you can write. See here what is advantage. If you do second derivation and substitute C here, directly you can tell whether it is a maximum value or minimum value like. Why? Because it may come local minimum point or local maximum point. That is the advantage. Okay. One example we will take and again we go for exercise. Okay. Let us do. Okay. We will take one example to understand this first derivative, second derivative, local maxima, local minima. First of all, listen the question I am reading. Find all points of local minima, local maxima, local minimum value, local maximum value for the function f of x is equal to 2x cube minus 6x square plus 6x plus 5. We will do this example, then we can understand little bit more elaborately the concept. Okay. See here, one function they have given, okay, normally, and they are asking us to find local minima, local maxima. Accordingly, local minimum value, local maximum value, if it is existing. Okay. See, what we have to write? First we have to write, copy again this function f of x is equal to 2x cube minus 6x square plus 6x plus 5. Okay. Okay. Now what you have to do? Second step you have to do f dash x, first derivative. Okay. First derivative, if you do, automatically 6x square minus 12x plus 6 will come. Okay. Afterwards, what you have to do? You have to make equal to 0. See what I am doing. F dash x is equal to 0 implies 6x square minus 12x plus 6 is equal to 0. 6 if you take common, x square minus 2x plus 1 is equal to 0. Okay. See again what I am writing. 6 into x minus 1 whole square is equal to 0. X minus 1 whole square is equal to 0. X minus 1 is equal to 0. X is equal to 1. Is it correct? First you see. Okay. X square minus 2x plus 1 means x minus 1 whole square only. 6 I am sending this side, automatically x minus 1 whole square is 0. Then square, that means see, square means 2 times you are doing. 1 time even if you do also 0 only will come. See, square 0 means normal function, the value also 0 always. Okay? 0. X is equal to 1 will come. Okay. See, what is this x is equal to 1? X is equal to 1 is a critical point. This is a critical point. Okay. But we don't know this critical point is a local minima or local maxima or point of inflection. Okay. How to find? Go to second derivative test. F double dash x. Write down. F double dash x. F double dash x is equal to, you see 6x square means 12x minus 12. Okay. See what you have to do. You have to find at C at 1. F double dash 1 is equal to 12 into 1 minus 12, that is equal to 0. You see F double dash C, if it is greater than 0 means local minimum value, less than 0 means local maxima value will come. But equal to 0 means may come point of inflection, or else another thing will come, local minima, local maxima. See, when F double dash C is 0 comes, then go back to again first derivative. First derivative I have gone. You see F dash x is equal to 6x square minus 12x plus 6 is the first derivation. See, here automatically F double dash 1 is equal to 0. If x is equal to 1 means F double dash 1 is equal to 0. Okay. See what we are doing. We will take 2 points. Why? Because see, this point may be like this, or this point may be like this, or this point may be like this. You understand? See, this is the point, this is the point, this is the point. But in these three, any one will come here. It may be local minima, it may be local maxima, or it may be point of inflection. See what we are doing here. Less than C, that means less than 1. One value we will take and do. Okay. Where we are doing not in function, in derivation. In derivation we do, but derivative final result is positive, then this is increasing. Okay. Like that we have to understand. You see what I am doing. F dash 1 is equal to 0. Then see, I am taking x is equal to 1 all that is that point. Then x is equal to 0 before that point, and x is equal to 2 after that point. Okay. Immediately f dash 0 before 1, that is equal to, you see 0 0 plus 6, that is equal to 6. See, f dash 0 is positive. 6 means greater than 0, positive. Positive means see, this is coming positive, or this is also positive. This option has been closed. Okay. Now let us take f dash 2. F dash 2. F dash 2 means 2 square. 4 into 6, 24 minus 2 into 12, 24 plus 6. You see 24 cancel, again 6 will come. F dash 2 is also greater than 0, positive. See here again positive means this one. This has been closed. Why? Because here negative is there. Negative should come. But in both areas, before that critical point, after that critical point, both areas positive has come. Positive derivation has come means x is equal to 1 is point of inflection. This one. You understand now? Now you can understand easily by this example. What we do, we go back to our exercise 6.5. 2 questions we have completed. Third question we will take. 8 parts are there. We will do 2 parts in this class. Okay? Let us go. Okay. First understand the question, same like earlier question only, example only. All you have to find if available. Local minima, local maxima. Local minimum value, local maximum value, all you have to find. But they have given f of x is equal to x square is the function. Okay, see, now see, this is third part, third question, first part. 2 questions without derivative test we have done, and how to do and all we know we have done. Okay. That also you have to know. Why? Because basic to step by step you have to upgrade your thinking or whatever it may be, process or concepts or whatever. See, for first question, second question, basic concept we have done. Okay, basic concept we have done for first question, second question. See, those questions also you can do with the derivative test easily, it will come. But you see, you have to know that process also. That was the basic process. That is why I have made you to make in that process. Okay. Now we will change process. From third question onwards, we will change process. Third question onwards, even the word also local has come. Earlier local was not there. Third question onwards, the process is first derivative, second derivative. Both we will do. Okay. See what I am writing. F of x already is there. First derivative I am doing. You see, f dash x is equal to 2x. Is it okay? Okay. Definitely okay. You see here, afterwards what you have to make, f dash x is equal to 0 you have to make, which implies 2x is equal to 0 comma x is equal to 0. You see, x is equal to 0 is the critical point here, critical point. This point may be local minima, local maxima, or point of inflection. We don't know. Okay, let us see with second derivative. F double dash x is equal to 2. d by dx 2x is equal to 2. Okay. Now you tell me f double dash x is greater than 0. F double dash x is greater than 0. Why? Because see, even if you want to substitute also x, here there is no x. Before substituting itself, positive value is come. Greater than 0. 2 is greater than 0. Okay. When f double dash x is greater than 0, x is equal to 0 is point of local minima. Second derivative greater than 0 means minima. Second derivative less than 0 means maxima. Here what is there? Local minima. Okay? X is equal to 0. Then you can find local minimum value also. Find, write down. If local minima comes, local minimum value. Local minimum value, comma, f of 0. See, f of c you have tried. Here c is 0. Okay? F of c. See, f of c is equal to 0. That means here both are 0. Okay? Both are zeros. Local minima is also 0. Local minimum value also 0. Okay? To understand this concept, see here f double dash x is directly greater than 0 has come. Earlier equal to 0 was there, again we have gone back to first derivative. But here not like that, greater than 0 has come. Okay, that is the advantage of this procedure. Okay, let us go for second question, second part of this. Okay, see, this is second part of our third question. Same, local minima, local maxima, local minimum value, local maximum value, how to find. G of x they have given. Same like earlier, we will do first derivative. First derivative means what? G dash x is equal to 3x square minus 3. Okay. See, you have to make it as equal to 0. Then if g dash x equal to 0 gives, okay, 3x square is equal to 3, x square is equal to 1, x is equal to plus or minus 1. That means here critical points, two critical points are there. C is equal to plus 1, C is equal to minus 1. Okay. So at each point you have to do second derivative test. Let us do first second derivative. Second derivative, g double dash x is equal to 6x. That's all. 6x. Okay. See, 6x, you have to substitute this critical point value, then only you can know whether this is a local minima, local maxima. Okay. See, here two values are there, then separately two values you have to substitute. You see what I am doing? First I am substituting plus 1. At x is equal to plus 1, g double dash x is equal to 6 into 1, that is equal to 6, which is greater than 0. G double dash x is greater than 0 means x is equal to plus 1 is point of local minima. Why? Because greater than 0. Point of local minima. Is it okay? Point of local minima. X is equal to 1 is point of local minima or local minima. The local minimum value you can find. Write down local minimum value. Local minimum value f of 1. F of 1 is equal, sorry, g of 1. G of 1. Here g is there. Okay. G of 1 is equal to g of plus 1. G of 1 is equal to 1 cube minus 3 into 1. That is equal to minus 2. Is it okay? Definitely okay. Okay. See, we have done only 50%. This one is also there. At x is equal to minus 1, that also you do. At x is equal to minus 1, g double dash x is equal to 6 into minus 1, that is equal to minus 6. That means g double dash x is less than 0. Less than 0. Why? Because minus 6 is come. Here plus 6 was there, greater than 0. If greater than 0 comes, point of local minima. If less than 0 comes, means point of local maxima. X is equal to minus 1 is local maxima. Local maxima. Okay? Then local maximum value you can find. Write down. Local maximum value. Local maximum value f of minus 1. At local maximum point, local maximum value how to find? F of minus 1. Minus 1 cube. Sorry, this is not f, g. Minus 1 cube minus 3 into minus 1. Minus 1 plus 3, that is equal to 2. Okay? That means, see, local maximum value is 2, local maxima is minus 1, local minimum value is minus 2, local minima is plus 1. Okay? These are the answers for this second part of the third question. Okay. We stop this class here. Remaining 6 parts are there in the third question. We will do. And afterwards for fourth question again concept is changing. Absolute minima, absolute maxima is coming. Let us see in the next class what are all we can do. But these 6 parts we can complete in the next class. Okay. Thank you very much.